right, thank you. I'm a little bit on a leash today. At least it feels like this. I have very good news for at least one of you, because there's just a free seat. So if you like that one, pick it. Aside from that, thanks for having me here. It's really nice audience. So the talk today is about C++ Insights. And as Klaus said, I'm the creator of C++ Insights. Just for the statistics, who has heard about C++ Insights before? All right. Who used C++ Insights before? All right. So, excellent. But before we talk about C++ Insights, because it's a non-German talk, I like to introduce my last name. My last name is Fertig, which has an interesting meaning in German and in English. It translates in English to finished, ready, complete, or completed. These are really nice adjectives for a project state, for example. So people tend to think that their project is either finished, ready. When I'm on them, they miss the fact that the name isn't anything. So, however, while I introduced my name in the English talks over the last year or so, I learned a lot about it. I didn't know before, so I now know that in Yiddish it is understandable. Let's sort that. In Norwegian, it is pronounced and spelled a little bit different. It's more Fertig, if I pronounce it right. Matches. I learned a lot about how many people at least understand or are able to read German. Janis Rostrup, for example, is able to read German because he noticed what my last name means. And this leads me to the next problem I have with my own name, because when I'm tired, for example, and I'm checking into a hotel saying, yeah, I have a reservation, my last name is Fertig, and the person on the desk understands German and thinks he or she is nice and says, oh, Finnish. And one time I replied, no, I'm not Finnish, I'm German. Happened twice so far, but only when I'm tired. And there's a nice other thing, and it's a constant fight with my spell checkers. Because in German, Fertig is an adjective which is spelled with a lower first letter. However, as my name, it's spelled with a capital F. So we are constantly fighting who is right, the spell checker or me, and it depends very much on the context, so I cannot train it properly. So anyhow, let's go back to C++ and C++ Insights. This is a very trivial statement, or 2 lines of code, I guess. There's my type, I, initialized with curly braces, and then this variable I is incremented, supposed increment by 1. Everybody has seen code like this more or less so far, right? And especially when I talk to students at the university, it's hard to tell them why to use post or pre-increment. Okay? Coming from C, it doesn't matter that much because there you don't have classes and stuff like these. But in C++, it makes a difference whether you use the post or the pre-increment. For the pre-increment, you may create a temporary you don't need or never use, like in for loops, and it's just discarded. It's noise if the compiler is not able to optimize it away. But just looking at this, it's hard to tell. It depends on the class. And then and this is an excellent stage for that, then I'm telling my students, yeah, well, think, at this I, between the I, or replace this I preceded with a dot operator plus plus. And this is a really annoying exercise. And people look at me and still, well, what is he now talking about? So I create slides or created slides in the past saying, okay, look, it translates to this. Okay, and of course, there's another thing you have to know. If you pass a 0, it's the post increment. If you don't pass a 0, it's a pre-increment. Sure. Right? So it doesn't matter if you pass a 0 or 1 or 2. Compiler usually passes a 0. That makes it a post increment. But that all depends on your type, if it makes a difference. If a temporary is created or not, it's only created if it's a class. If it's a built-in type, it doesn't really matter that much whether you're using post or pre-increment. There's a lot to talk about, and in my experience, it's sometimes easier to show things. That's one of the reasons why I created C++-insights. Another one is this example. What we have here is a hopefully rather trivial function. It's called max. It takes two variables, a and b, and it compares them and tries to figure out whether a or b is the greater one, and then returns the value of that variable. I use this in my short program. I create two variables, a and b. I initialize a with 1 and b with 65,530. And then I use the printf to print out the number, which is the greater one. So, first question. What's the output? 1. Excellent. Why? It's casted to signed. So basically, we are talking about integer promotion rules. And compared to the example before, this is way harder to explain. So before I switch to the C++-insights view to show you the implicit conversions, those of you who responded with 1 or with implicit conversions, how many implicit conversions are in this program? I accept 2 answers.
3.
So we have 3. It's not that we are selling anything, but does anyone bidding more than 3? 4. Okay, you found another one. Okay, we are getting up. We're talking about 5 million now, so come on, guys. More money. So, 1. So we have 1, 3, 4, 5. 6. No, not 6. Okay. I think that tells us that it's not that easy. So, let's have a check. This here is C++-insights, or better, the website, the web front end of C++-insights. The tool itself is a command line tool. I'll talk more about this later. But for all of those of you who haven't seen it, this is the website. You put in your source code on the left, and you get out C++ code on the right. It's the most awesome tool in the world, because essentially you're putting in C++ and getting out C++. It's amazing. I'm making millions with that at some point, probably. But back to the topic. So this is the exact same program as on the slides. Now I have to check my options. All right. So remember what we had. We had 1, 3, 4, 5, and a removed 6 conversions. What C++-insights shows you is what the compiler in this specific scenario, Clang, does with your source code before it compiles it to binary. It's when it parses your C++ code, it generates an AST. I will talk more about this in a couple of minutes. And what you see here is the transformation back from the AST to C++. So it's not what I think, at least in a lot of places not, it's what Clang thinks. And what we can see here is that inside of max, we have the first implicit conversion because there is no comparison of shorts. There is only a comparison of ints or larger. So I have a cast here to an int of a and of b. Next, when calling max and passing b, which is an unsigned short, it is converted to signed short because the function takes two signed shorts. Okay? Third implicit conversion. Third implicit conversion is max also happens to return a short, but printf takes integers as arguments. These are the four. There's another one. These are the four conversions. We can increase this if we tell the tool to be really noisy. I usually turn it off. And then we see, well, to be fair, the 1 here is an integer and not a short. So it's downcasted to a short by the compiler for us implicitly. And the same goes for the 65,000. That's an integer, not a short. Usually we do not care about these things. Often we are happy that they happen for us. We use implicit conversions. We program conversion operators and stuff like these. But in this specific example, because of the numbers I chose, it may be surprising because the output is 1 and not 65,000. So 1 is the greater value here. Because of all these conversions, we are ending up with, instead of 65,000, with a really small negative number. So, and this one is not greater than 1, so the output is 1. Was there bitten by a bug like these? Yeah, me too. Oh, as I forgot is to mention in the beginning, if you have questions, please ask them directly, okay? Raise your hand, make some noise or whatever. Yeah?
I would have expected that printf takes them like varargs and not really integers. I'm kind of surprised that the shortest conversion is there.
You're talking about this cast, the displays. I would say I have to repeat the question. Thank you. So the question was that it is surprising that we have this cast at the printf here, which converts or casts our short back to an int, because the assumption is that the printf is able, due to the var args, to take a short and not just ints. And I think the reason boils down to, yes, printf is able to output a short and it will pick probably a short later from the call stack, but we can only pass integers to the var args. That I think is the underlying reason, because essentially what we are doing there is giving a stack pointer and saying, hey, here's my stack and now feel free to find a short there. Does this answer the question? What would it be if it would be a long? So say we are tampering with the example and saying, saying here long, and we are forgetting about the just for the printf. Yeah,
just changing the return type of the function.
Okay, now I've changed everything, so it doesn't.
I would say long, because I don't know.
You like long.
Probably same as sorry, long is probably same as.
Okay, now I'm doing too much. Let's say it's a long here. Okay, now it only complains that my format argument is wrong. So I think it's the same reason. Essentially you cannot pass types smaller than int to the var args. It's not so much the printf, it's more the var args that's the printf based on. Yes?
Wouldn't it be easier just to switch on the context log warnings? Than using function as way to do? Maybe it's for JSON, but for this particular purpose, I think.
I'm absolutely with you. So thank you for the science. The question was, wouldn't it be easier to just increase the compiler warnings for these scenarios instead of using such a tool? And the simple answer is yes, please do that. Because you should not hack your company's source code in the online website, okay? I don't get the source code, but potentially you shouldn't do that. The tool is maybe more for education purposes. My personal experience with turning up the warning level is the following. If you just turn up the warning level, nobody cares. Okay? You have to make them warnings as errors. If you have a big enough project and you turn warnings into errors, you're stalling your development for a long time. And I've seen bugs being introduced because people fixed those problems without understanding them. And the code worked before, sadly.
If I add such a tool to the chain, nobody will care either.
Yes, it's not a point making your software better by using that tool. The point is, pardon me, but making your knowledge better, if you like. The tool doesn't help you with your existing source code. It can improve your view on the source code, and it can help you to understand what is going on there and why maybe you are getting 1 here in the initial example instead of the 65K. That's the point. Warnings are there. Anyway. Other questions? Yes?
Speaking of hacking the company's source code into that tool, your SSL certificate seems to be broken.
So, okay, the remark is that my SSL certificate seems to be broken, which is true and false at the same time. It's true for this. The reason is my laptop is offline. I'm faking the website. And I never bothered with faking the SSL certificate. But thank you. The real website should have a valid certificate. If you find this one with an invalid certificate, please tell me. Other things? All right, now that we have seen C++-insights a little bit in action, here's a quick summary. So it can show you what's going on. As we also already answered a little bit, it's not the idea to improve your entire company's source code. It's more about the knowledge and the basic about what's going on behind. It makes invisible things visible, and I really like C++, so I like that the things are most of the time invisible, but the experience there in teaching, it is quite helpful if I can make these things visible again, just for understanding reasons. I try to create valid C++ code out of C++-insights, which is not always easy, it's not always possible, but in general, it's what works. I started creating this when I was preparing another talk, and the talk was about C++ 11 features at the time and a few 17 features, and I tried to explain how they are implemented behind the scenes, and I found myself preparing the slide, learning something, changing the transformation on the slide. So I did this 2 or 3 times, and I'm not a person liking to do things multiple times over and over again. So that one day I was sitting there and thinking, okay, I can create a Python script which some regex parses this range-based for loop and creates the for loop behind. Or I can do it a little bit better, and I thought, okay, I can use Clang and the AST there to do it more properly, and well, the task was easy. I aimed for 3 or 4 statements, range-based for loops, structured bindings. I'm not sure if Lambdas were an idea at the time, but it was also a context per if. So easy things, a day or 2. Okay, to be fair, I underestimated how hard it is to get into the internals of Clang, so it took over a week or so until I had a running prototype. And at the time I had this, I realized, okay, I can do more because things became more reachable, more easy. And at this time, cpp-insights is able to translate a lot of things. There may be a few things that left out, and if you have time at the end of the talk, I can show you the most recent example, which isn't working yet. So anyhow, it's on GitHub. It's open source, and you've already seen the website. Remember, the real one has a real certificate. Should show a green icon and not a red one. But it also comes with some limitations. As I said, I like to produce valid code. Valid code has an advantage for me during development because I use the generated code, transformed code, and compile this code again to check if it is really C++ code I'm generating out of this. And so this makes my own testing easier if the resulting code is C++. And it makes it easier for users, because if I'm creating out some arbitrary piece of code, you cannot use it really much. And I have a good imagination, so I would be able to create a lot of things. So, but the limitations are still there. So the first and most obvious one, hopefully, is it is a Clang-based tool. That means that everything you're seeing, every transformation, every warning you get, and things like this, what Clang sees, what Clang does. GCC might do things slightly different. The same goes for MSVC. Unfortunately, they do not have such a great infrastructure for tooling as Clang does. So currently there is no plan to have it in the other compilers. It would be really useful, I think, to see the implementation differences there, at least for me. But in general, it is a good view, but in some cases there may be internal differences between the major compilers. I use the latest release version for Clang as a stable version for the website. That means that not all the most recent C++ features are probably in there. So currently we are heading from Clang 9 to Clang 10. Clang 10 is in release candidate 1 or 2 is out. So with that, there will be more C++ 20 features available. But for now, it's mostly pre-C++ 20 and all of 17, 14, and 11, and so forth. Because it uses the Clang's AST, I'm not sure if you're familiar with the compiler's pipeline or compiler's chain. So what first happens if you stick in your source code into the compiler, something called the front end takes over and parses your source code. To be fair, one step before that is the preprocessor, who more or less does text replacement to your code. In Clang, I think it's coupled with the front end. So forget the preprocessor, it's done, it's text replacement, and then the front end kicks in and parses your C++ code. And it creates the AST. And it does, on this way, a couple of easy optimizations like constant folding and stuff like this. Also template expansions because, or instantiations because it has to. But it does not do any further optimizations. So you will not see the result of optimizations. If you run the tool on your own, it will not make a difference if you pass -0 or -03 to the resulting output, because that happens in a later stage. Okay, I got requests in the past to show that, and yes, that would be great, but there is too much knowledge of Clang going on in between. And okay, not all statements currently matched. I'm working on them, but a few are missing. There's one more limitation, and that's when it comes to templates. Templates are really great, really beautiful. And I have an example here. I have a function template called func and a really simple class called demo. And in main, I'm calling func with demo. And if I do translate this in C++-insights, which I can, then we will see that C++-insights first shows us, oh, there's a specialization and or an instantiation for func with demo. Thing is, this is wrapped in an if-def. And the reason for that is that the code as provided here, the resulting code, would not compile. Because at this point, the class demo is not known if you compile it again. Okay? The same, more or less same code would compile if I put the class demo before the function. The reason is simply that the tool shows the instantiation directly after the function template itself or the class template whatsoever. I haven't tried to figure out the best place where to put it, and I think it's not possible in all the cases, but in average it may be possible to make it better, but for now this is the limitation. So you see the things, but I try to keep the resulting output stable and compiling.
So if you, sorry.
Yeah.
So if you just put the forward declaration and put the definition button, so
That would, so you're saying if I use a forward declaration and putting the class as before behind it, that would again compile then, yeah, because then there is a type. Other questions? So I've talked about an AST. Who knows what an AST is? All right, that's an AST. What's the C++ program behind it? Because that's what C++-insights uses to transform it back. Yes. It's the most simple program you often start learning. It's a hello world. It says hello C++. Okay? It's this one. Amazing. Now, this one includes IO stream. This is a standard header. What I've shown here is just a small piece of the resulting AST dump Clang does. What do you think? Looking back at the C++ program, let's say a number of lines. What is the resulting number of lines you get when you ask Clang to do an AST dump of this particular program? 10,000. I heard 80,000? 15,000? 1 in a million. More than a million. More than a million. Okay. Watch this. This is the beginning of the AST output, okay? And without any further ado, this is the final number. Roughly 190,000 lines of AST output. That's the reason why I ask people, please, 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 if you file an issue report, if you can do it avoid including standard library headers or types. If you can reproduce it with your own type, it's much easier for me. Because in all that stuff, I have to go through and find where my bug is. And in a lot of cases, it has nothing to do with the standard library type. So I checked this today and I thought, okay, I know it's page-wise output, but I never realized it's that much. Okay, a little bit back to C++. While developing the tool, I learned a couple of things. Things I knew before, but I learned new things about them. So here's an example. I have this function func here, which takes one parameter x, and it has a default argument, or a default value in this case, 23. It's easy. It means I can use func in main without passing in any parameter. I know this for years. I never bothered to ask myself the question, how does this work? Okay. How does this work? Oh, it's so easy. Well, the compiler just inserts the value for you. That's it. The original function or the transformed function does not longer have a default argument, but in all the places you do not pass an argument to that function, the compiler inserts the value you asked for before. That's it. Nice and easy. Never thought about this. Another thing I like to use the tool for is initialization. And there are entire talks solely about initialization, so this is just a very brief portion. I have the 4 variables A, B, C, and D. All of them are jar arrays of size 5. And now the first one just declares it and ends with a semicolon. The second one uses empty curly braces to initialize the array. The third one uses a combination of curly braces and 0 to initialize that thing to 0. And in the fourth case, sometimes people don't like values initialized to 0. They like to be distinguishable. So the person here picked 77. I personally prefer XAF, but that's just because my initials are representable in hex. So what's happening there? For A, I believe everybody knows that's uninitialized memory, right? So B, it's 0 initialized due to C++ 11's initialization rules of the curly braces. C, C is all 0, and that's the bad thing. Because I experienced that people are under the impression they can control with what the thing is initialized, because 0 obviously works here. And that's why we have the group D, which then thinks, well, I like 77, okay? And the resulting output is, yeah, well, it's an array, and you're doing an array initialization now. So it's the first value that is initialized with 77, but the rest is still 0. And there's a nice side effect, which you can also see here, because the first 0 for C, that's the one you requested, and that's an integer. The others are the correct jar representation of 0, which the compiler fills in for you. And if we now turn on the verbose mode again, just because we did it in the beginning, we can see, oh yeah, there's once again a cast. So this is what I use sometimes to show people, yeah, I also like 77, but in this case it doesn't help.
Sorry, turn to debug release, doesn't change anything?
If you
Turn to
So the question is, does it change anything if I put that thing to debug mode? Because in MS we see it shows you the values in the array. Did I get this right? Okay, I cannot put this in debug mode here, and I believe it would not change anything because this is what the standard says essentially, and maybe MSVC has some kind of additional help or assistance for you to guide you that this is not what you want. Other questions? Yes?
No, in debug mode, it initializes to 0, but I don't know if it's...
You're saying in debug mode it initializes to 0, but I do not get a reason. What's the point? Yes, it initializes to 0. That's what the standard says. Ah, you're talking about the first case. It shouldn't do that. Yes?
Can you go through older standards to see what changes? Like this is C++.
Oh, yeah, that's an excellent question. We cannot go back to 98 for this. So the question is, can I change to older standards to see what's happening? And I believe in this example, nothing changes because I cannot go back to 98. And there is nothing changed, at least to my awareness, between the modern standards. But I will show you, and if I fail to remind me later when I show something about Lambdas, there you can see the difference. Yes, that's another nice thing where you can use the tool. More questions? Then moving on. In-class member initialization is another thing we got with C++11, and sometimes the question pops up, how does this work? More specifically, because in this example, I initialize I with 9 in the constructor, and I also provide a default value as in-class member initializer for I with 0. So people sometimes ask me, okay, do I waste resources because that thing is initialized twice or initialized first and then copied over? And that's once again something where I'm really impressed how easy things are. I'm not sure if I would be saying the same if I were a compiler writer, but I'm not, so I can say this. So this is the transformation, and the rule is if you override it in the constructor initializer list, that value wins. So the 9 remains here, and if we are looking at the in-class initializers we provided before for the members, at the place of the members they are gone, but all of them are moved into the initializer list of the constructor. So we can see here our vector is 1, 2, 3, and our std string is hello. So there's no duplication. It's just a little bit of syntactic sugar the compiler, as a good friend of us, does for us. Questions to that?
So if you have multiple constructors, then this will be replicated code.
If I do?
If you have multiple constructors.
If I have multiple constructors, you're saying, let's say if I have something like that. And your question is now if that would be duplicated. So let's leave it like this. Hopefully I didn't make a typo. Is this, your point is that then this is duplicated. And yes, the answer is yes, this is duplicated because you have another constructor and your value needs to be initialized at some point. You can use constructor delegation if you like to reduce this here a little bit, but clauses.
The code is already in one place only. So it's on the right hand side it's duplicated, but not on the left. The left is the important one.
Left is the important one. Was this your point, that the left side is the important one? No. You're talking about the resulting code, right?
Exactly one initializer for all three
Yes.
Only once.
Yes.
Yeah. So perfect.
You're writing it at the left once,
Yes.
and depending on what constructors you're using on the left, you get one initialization per constructor for all the members.
No duplication.
Yeah, no duplication in that sense. It's the same what you would have to write or what you have written before on the left. So you first.
If you change the int to the last line, then it would also change the order, I guess.
If I change the int to the last line, like this, you're saying, and if I recompile it, then yes, the compiler maintains this order. And by the way, I recently learned that we have not standardized that the compiler has to keep the order. Yeah, at least not if we are crossing areas, if we are coming from public to private and back and forth. So, but every compiler does keep the order. So we are looking into just saying, and this is how the standard says it too. There was another hand. Yeah.
Doesn't give you any warning if you only, for example, if you miss some to initialize, you will never get any kind of warning. You know what I mean? It's like you have 3 plus initialize.
Yeah, saying I do not initialize that std string here. Is that your point?
Yeah, a little bit combined with what you put in the constructor that you say, okay, some kicked in the int plus initializer, some doesn't kick in because you are overriding, stuff like that.
I'm not sure if I'm getting the question completely, so let me try it. So first of all, I always teach use the in-class initializers consistently, so don't mess and only initialize a few of them and the other not, because then it's really hard to know what to do. If you follow that rule, I would say you cannot miss to initialize a value. What you still can end up with is, say you have a class with multiple std strings, and you have a constructor taking one, which is supposed to initialize the first string, and you initialize the second string instead. Then you can mess up things, because the compiler will then use the default value for the first string and put the wrong value in the second string because you ask so. But there should be no other possibility to confuse that. Other things? Oh yes, and then we have Lambdas, of course. The new thing in C++ 11, the feature which was tackled the most, at least in the beginning of C++ Insights, and had to do a couple of fixes. It seems pretty stable now. So what we have here is a const-jar array with the name hello and the string hello MUC++. That never works. Okay. And after that, we have a lambda capturing that string by reference, because the printf in that lambda uses it to print it out, and the lambda is directly invoked. So what is behind this neat little piece of code? If I do the transformation here, we can first see a couple of side things. Well, the compiler knows the size of the array. It has to. And now it tells me also, if I can calculate it myself. And then the compiler creates a class for me for the lambda. And the name you're seeing here is made up, because the compiler, in this case Clang, does not bother to pick a name, because it's just an internal type. It has a pointer, and the address of the pointer is more or less enough. Yes?
I'm curious, because it's, I guess, line number and position in the line. Did you have the position in the line from the beginning, or is it something where you didn't think people would have to declare multiple lambdas in one line? You learned the hard lesson, then you added it?
So the question is, the guessing is that the first number is from the line and the second from the column, and that's correct. And the question is which column I do pick, and does it survive multiple lambdas in one line? And the answer is multiple lambdas in one line, it survives. Yes, because you cannot declare multiple lambdas in one line at the same column, except for variadic templates, which we will see later. And then it fails. And I haven't found a way to make that stable because I intend to not keep internal state, so I could just have a counter and increment it, but I also need it later for reference when I'm creating the lambda or referring to it. So I need to have a way to get back to it. And that was the easiest one, and aside from the variadic template, the most stable one. Other questions so far? Okay, the compiler creates a class for me, and in the public section, it puts a call operator. And the call operator is the matching signature to my Lambdas definition. In my case, the call operator does not take any parameters or arguments, so it's empty. And inside the call operator, I find the printf, which is in the Lambdas body. So it's just syntactic sugar transforming from the one representation into the other. And then, of course, the compiler takes care of my captures. And in this case, it creates a char array, which is a reference to the initial array of size 14 to reference my hello string. And then, of course, it takes care of initializing that entire thing. And below here, we have the invocation. When I invoke the lambda, the call operator of the lambda itself is simply invoked. I find this really beautiful because essentially it's C++ 98 code. But it's so much nicer to write this and maintain this instead of the code on the right side. What's the... You're asking about the const expr, which is commented. So the thing is, the const expr here as a comment is for the following reason. Since C++ 17 lambdas are implicitly const expr. We will see that later. That means that the Clang puts const expr to all the functions that seem viable. But as we are at the front-end stage, the const expr evaluator, as far as my knowledge from Clang goes, is not finished with analyzing what is inside of the body. So it's a tentative const expr at this point. And in this specific case, that lambda cannot be const expr because it has a printf in it. But at this point, Clang tells me, yes, it is const expr. Because for its internal added const expr things, it can just take them away later when it hits the backend and sees, oh no, there is an element in there which cannot be const expr. Okay, I remove the const expr. It cannot do that for your code because then it has to tell you, hey, there is a function in it which cannot be const expr, so fix that. That's the difference, and I haven't found a way to query Clang at this point whether it is really const expr or not. I was a little bit looking into const eval, but that doesn't help either. Other questions? Yes?
Would this code compile like this? Because you have a class definition with emphasis 7 and it's the same name as the variable.
Yes, that would compile.
Because it's inside a function. Particular case.
Put it on the left side again.
That would, yeah, but I also have another tool here, Compiler Explorer, and I also use this. Yes, that's the correct answer here. So the first answer is if my laptop manages it, we can now see that thing happily compiles. And if I turn on the output, yeah, we can also see that it works. Not just that it compiles, it also works. And that was, in fact, a change which came in with Lambdas. I tried to track this, but I haven't figured out when in the standard it was introduced. But also, to my knowledge, this is something that changed for Lambdas, that you can have structs or classes inside of a function declared. You cannot do this, and that's the next point where C++ Inside fails. You can still not have templates or template specializations within functions, which is interesting for the next part, because sorry? A function and a class with the same name. No, I'm not saying that.
No, yeah, that was actually my question.
Yes, you.
The variable has the same name as the class.
Okay, sorry, I misunderstood that, and now I closed the tab. I closed both tabs. So, and now you cannot see anything, and now it's better. Okay, your question is, I create a variable here with the name and a type, and this is distinguishable. Types and variables are different things, so that works. Sorry? I believe so, because that's nothing special.
This actually comes from C, and I think C++ would have wished to change it, but they couldn't.
Yeah. Yeah. It's easy there, speaking as a non-compiler dev, because these are two different things. Does this answer your question? Yes. You're not satisfied, but it's an answer.
Sorry?
Yeah.
Lambda captures something which isn't used in Lambda is taken away from the frontend, or does the optimizer take it away?
My most favorite answer to any question is, it depends. Okay? Okay, going back to this example, let's say your question is, if I capture something and don't use it, what does the compiler do with the Lambda? And first of all, I use the same Lambda, and I say capture by reference, but I don't use anything, then I essentially end up with an empty Lambda. Thing would be the same if I say I capture that thing by copy, then I end up with an empty Lambda. Things are different, and I remember that Scott Myers, in the beginning at least, told you to name your variables explicitly you like to capture. And if you're explicit, the compiler obeys your wish. And now the it depends kicks in. I would assume and believe that the optimizer is able to remove this. On the other hand, we are looking at the class with a member, and the compiler is not really allowed to optimize away unused members. So I'm guessing that will be there. I can show you other examples when it comes to std strings, because they have side effects when allocating memory. They do not go away, for sure. Yes?
If you capture by copy, should not kick in the copy constructor, and then it's like to have side effects and should not be allowed to remove it away?
Yes. The answer is if the copy constructor kicks in, this alone is a side effect and should prevent the compiler from optimizing it away. I'm not sure how deep compilers can look and can figure out that really nothing is going on there, but in general, I'm on the same side. I believe it's not optimized away. Yes?
This advice from Scott Myers that you should name your captures isn't valid anymore, or is it time you're doing it?
Remember my favorite answer? It depends. Either the advice was never valid or it's still valid. Nothing changed there. It's just that you need to know what you're doing. And the moment you're stating which variable should be captured by copy explicitly, the compiler will do it for you. And it always has since C++11. And if you do things right, you have what I think Scott had in mind, you have some documentation what that thing captures. And it prevents you from accidentally capturing or modifying other variables. I think that was the key idea. But if you're refactoring that thing and overlooking one of the explicitly stated copy captures, it's only interesting for the copy captures more or less, then it's up to you what you think of Scott's advice is good or not. That's essentially this. I think your hand was first.
So to be fair, compilers are able to warn on unused captures.
Yes, more, but yeah, recent compilers warn on unused captures nowadays. So that helps a little bit to still say that Scott's point is valid.
And also to make it complete, Scott said be explicit. You did not say you have to copy, so capture by value. You said be explicit, write the name, and perhaps capture the reference. But you wanted to, so the problem he had in mind was that you can easily accidentally capture this pointer without seeing it. This leads to lifetime problems.
Yes. So to summarize this, Scott's point was more or less to be explicit and not always to capture it, because the greater danger, I think, comes from capturing by reference. And there potentially is a greater advantage to be explicit about what you're capturing by reference, because this you can potentially modify the outside value. So now I lost track about the hands. You're still up, sir. Should the call operator be implicitly no except? If it's not no except here, the answer is no. But don't ask me why. No, I don't have a good idea. But usually I show the no except tags if they pop up. So in this case, Clang doesn't tell me, or you just found a bug, let's be honest. But it works in a lot of other places. Other things? Then, let's talk a little bit more about lambdas, because with C++14 we got generic lambdas. And to this day, this is still the only place where it is valid to have auto as a parameter type. Okay, because C++20 is not a thing yet. Next week, it may be different, hopefully. So, we have the ability to say auto here. And that makes it a generic lambda. But what is happening here behind the scenes? And just the following. I guess if you have, as a compiler dev, implemented the first version of lambdas, it's really easy to say, hey, this auto keyword, it means that you're defining a method template within your class. So this auto roughly translates into a lambda having a function template. Here I have now the call operator, which takes double, and I have another call operator which takes an int, and above here I have the template definition for all of this. So this is what generic lambdas are. They bring templates into your lambdas. Questions to that? Yes?
Is there any control on what this auto will take? Or
No.
It will be whatever you put in.
You can, of course, limit it with static asserts afterwards and such things. It will be much better with C++20 when we have concepts. Then you can constrain the lambdas type much more. But so far, it's like when you write a lambda saying, like you write an ordinary function template, which takes a t. Yes?
Actually, the error messages in time for B doesn't supply or support the correct operation.
So the question is, how ugly are the error messages if the type you're passing in does not satisfy one of the functions which presumably or assumed to be used, like you're passing a std vector and calling print on it, something like this. Probably as bad as with a regular template, just that's wrapped inside a class. So coming back to, just to hold my sword, coming back to the limitations, this is not valid C++. You cannot put a method or method template specialization in a class. The specializations have to go outside of the class. I can do that, but next thing is they can still not appear within a function. And lambdas are in functions, typically. And the rules also say that lambdas have to be declared at the most narrow scope from the compiler. So it would still not be valid to move the entire lambda out just to get it compiling. So that's another reason for the ifdefs. Just a moment, you had a question there. In line 7, on the right side. A bug. But probably do not report this yet, because I am using an unstable version here, just for the fun, because I like to show some new thing later, and maybe I messed up something there. So I take note of that. No, it's not a hidden feature, sorry. But I can try to squeeze in a paper to promote it, but I have no idea what it should do. Declare auto bit field or something like this.
Just out of curiosity, what will be the decal type of the L variable?
What will be the decal type of the L variable? Let's say you're saying something like this.
Something like that. What will be the LL?
When I find the LL, I'll tell you. Here we have it. It will be the class type. Okay, see that way, you declare the class for the lambda, and if you are asking for the lambda's variable with decal type for the type, you're getting back the class. Yes?
So as of today, we cannot have template type lambdas, right?
Yes, that's a C++20 feature.
Okay. So it's confirmed it's coming?
So the question is, to this day, we cannot have templatized lambdas. And if it is confirmed that it will be coming with C++20. Well, next week is the Prague meeting, which is the final meeting for C++20 as the current plan goes. And as far as the papers that have been submitted go, there are no plans to remove that feature from C++20. So by the end of next week, I can tell you the truth.
And why didn't it make it earlier?
Why didn't it make it earlier in the standard? See it that way. See it that way. When we develop C++, it's like regular software development. You start with a new feature and you are ready to ship this, but you're not sure if you really can implement the rest or what are the implications of the rest. And then you delay it a little bit because you have an agile release train model-like thing, and so it just ships with the next version. And that's basically this. Sometimes compiler developers say it may be hard to implement, we have to have a second look at this. I'm not sure what the exact reason was there. Maybe we missed it in the beginning and it was too late to squeeze it in later. It seems natural, I would agree to that, but there's not time for everything. Yes, Andreas?
So I'm wondering, since you know all of the possible instance, all of the possible specializations of the different Lambda operators. Could you just, instead of writing it as templates, just have overloads for the function call operator?
So the question is, because I do have the knowledge, or the Clang has the knowledge of all the template instantiations in that place, if it cannot just simply create overloads for, or instead of the templates. Well, the first part of the answer is probably yes. Potentially it changes things, because then it's not longer a template. And yeah, the different rules would apply then, because then implicit casts would work, which do not here for, but yeah, that's partially true because you cannot specialize the type. That would be true later for 20. Okay, I don't have a good argument. It's a good question. Maybe ask this next week. Yeah. Other questions?
You wanted to show this through all the different standards?
This was not a one, but we can use that one. Can we? No, let's stick to the idea. We do this later. We can do this here, but I'm not sure if I have something special planned for later. So as we talked about, these are templated lambdas. They are coming with C++ 20, fingers crossed. What we can do now is, no, let's skip that part. So these are templated lambdas. What we can do here is we can now apply the angled brackets and type name T to our lambda after the capture list. Aside from the type name T, we can also say size T, so we can also apply non-type template parameters. At this point, it's not limited to types. Essentially, we can do everything with templated lambdas that we can do with usual templates, including concept stuff. And if you look at this in C++-insights, we simply see no difference to the generic lambdas because it generates template code for us inside of the class. The only real difference here is that we can see that this time the compiler does not have to make up a type name for the auto variable. Now I can say T or whatever I like. That's the difference. And of course now I can, and that was the point before, now it wouldn't make a difference because now I have a template, and if I say that template takes an T, which is an int, for example, then I would have a different outcome in comparison to function overloads because of the not implicit conversion rules. Questions about this? Yes?
But now there's a difference, right? Because now we only have one template parameter, whereas
no.
Also we would have two template parameters.
Ah, yes, yeah, okay, sorry. That's the key point here, yeah. The key point here is we can, with these templated lambdas, do things we cannot do with auto. Because with auto, in the version before, I would have to write 2 times auto for x and epsilon. And on the slides, the example is that then I can compile line 8 with generic lambdas. Because then my generic lambda takes an int and a double. And I have no easy way to prevent this. I can only static assert on the types inside of the lambda.
Will it still work, right?
Sorry?
It will still work, right? You say it's not what is, but it will still work, right?
With the templated lambdas, it's no length.
With the previous slide that didn't have that.
Yes, with the previous slide, so before I talk myself into much confusion. So this is the generic lambda version. And with that, we have 2 different types in a lambda, an int and a double. And I, for myself, think that line 8 should not compile because I should not compare an int and a double.
But that would work, right?
That would work, but now you're looking at implicit conversions again. It would work. And if that's what you like, it's all right. It's not what I like most of the time. I like it precise. And I like line 8 to not compile. And I can achieve this with C++20. And that's, thank you for that. That's because I can now say that Lambda takes exactly this type or only a single type whatsoever. Other questions? Remarks? Yes?
There was this invoke function. Where's the
The invoke function. That's here. This is in with C++20, it's the invoke function. And it's used with the, oh, it's not there because I don't use it. It's for a conversion of the lambda down to a function pointer. If you pass this lambda to a function taking a callable, or a function pointer to be precise, then there would be another function on the right-hand side, a so-called conversion operator, which uses this invoke function, the static invoke, to convert it down to a regular function pointer. Okay, and I think we are slowly running out of time. Now we are still talking about lambdas, because that was a question, so let's do this. What you can see here is, this is the C++20 version, and we have here a const expr. This is the same for C++17, because with C++17, lambdas became implicitly const expr, but the const expr goes away when I switch to the 14 standard. So you can see the little differences over all the standards popping in with C++-insights as well. How much time do we have left? 20 minutes. All right. Then let's do this. This is an example which I've seen and experienced in the real world. I have the struct keeper, which contains a std vector called data and a function called items, which simply returns data. To fit it on the slide, I didn't make anything private here, but imagine if this helps, the data is private and only accessible through the function items. Then I have another function called get that just default constructs a keeper object and returns it. Okay, not much fuss about this. And then I have a range-based for loop trying to iterate over all the items in the vector by calling get.items and printing the value out. Anyone likes to scream and run out of this room? What's the problem? It's undefined behavior, essentially, so.
There's a dangling reference of the data.
Exactly. So there's a dangling reference of data. And this is, again, something you do not see or cannot see. And there was a discussion to modify things to make it go away or make it better. However, in C++-insights, you can, if you understand enough, see what's going on. This part here, this is the transformation of the range-based for loop into a regular for loop, which, by the way, is another thing you can see there. And what we can see here is our get.items call. The result of this inside of the for loop is stored in a variable called range1. The name comes from the compiler. That it has to be there is in the standard. And in this case, it's a reference, but it's not a const reference. So I get no lifetime extension. That's why it's a dangling reference, and that's why whatever you're printing out there may or may not be the right thing or the thing you're expecting. That is a problem. And You can fix or work around this in C++20, or you will be able to do so, because there we have range-based for loops with initializers. Now I can say, like in a traditional for loop, I can define or declare a variable here first. I can now say, I have a variable called items, it's an R-value reference, so to whatever it leads. I call get, and then I use it here instead of my previous get call. And when we look at this, then we can see, okay, I'm now first creating an object or binding to whatever get returns, and then use it as before. So it's once again just a little bit transformation the compiler does at this place for me. Questions to that? This also solves, at least for me, an issue I had a couple of times, that I do like to, for example, iterate over a vector or a set, whatever, and I do not just like to print out the values, but also the position in the vector or in the array. And I had to declare all the time the index variable or whatever I use to make up the element counting outside of the range-based for loop, and with that it leaks in the adjacent scope and all. That's not what I like. And with C++20 I can now put this index variable simply inside of the range-based for loops declaration, and the scope is then limited to that of the range-based for loop. That's nice. With C++17 we've got auto as non-type template parameters, which allows me to write things like this. I have here a template which takes an auto sep, which is also provided with a default, which is a space, and then it takes a type name t and a couple of other t's because it's a variadic template, and it counts practically every argument, but it separates the arguments with spaces. So if I call it with print hello C++20, the result will be hello space C++ space 20. And I use a const expr if here to figure out whether or not there are more elements in the pack. If I once again transform this, we can say the instantiations of all the instantiations that this variadic template creates for us. So the first one is char6, char4, int, and a space. Then there's a reduced one, space, char4, int, and so on and so forth. So that's if I'm doing this with the const expr if and with recursion. It's what I'm asking for. If on the other hand, I do this with C++17's fault expressions, the code looks like this. And I'm now able to squeeze in a lambda to do the actual outputting. And if I do the transformation of this, then I first get only one instantiation of printf in this case, because it's no recursion there. It's expanded solely in this single instantiation. And I get a lambda. And then I can see what the fault expressions do, because this below here is the fault expression. So when I say here, for all the elements in the pack, call cout, space, and args, I end up with two calls in my case to cout, space, and arg. Operator calls to the lambda, separated by a comma. It's a really neat trick of the comma operator, because you can put as many values together as you like if you separate them by the comma operator. Only the last value counts, and in this case it returns void, so it doesn't matter. Yes?
Is there any difference in the order of the
Yes. So the question is there any difference in the order of the dots and the execution? Yes, we are talking about first binary or unary folds and then left or right. And it's more or less boils down, well, to math, where do you put the braces? If you are adding 3 plus 4 plus 5 plus 6 plus 7, how do you brace them to get the intermediate results?
Meaning if you do CR blah blah blah, comma, dot, it's going to be different? Or?
It's not that simple. In this case, I do not have a good example for this on the hand. You cannot easily switch this one, but for other cases, it would make a difference in the evaluation order, yes. But that's the intent there to control it. That's why you have the different choices. Other questions? All right, and here I have a new kid on the block. For all of those of you who are into sci-fi, maybe Star Wars, Star Trek, my girlfriend today is finally able to distinguish Star Wars from Star Trek, most of the times at least. I think sometimes she's just guessing and hoping she's right. We have the spaceship operator, the three-way comparison operator, or consistent comparison, whatever you like to call it. And it will be in C++20, and the promise there is that you have to write only one comparison function, and the compiler will generate all the other comparisons for you. Say you have to only write operator blah, 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 and you will get less than, greater than, less than or equal than, or greater than or equal, and equal or not equal. Have you heard about spaceship? However you like to call it. Okay, so you'll know what I'm talking about. How does it work? It's a great promise. Generate the other operators for me, right? Well, and the good thing is, I'm guessing most of you do not have to implement it, right? Is anyone a compiler dev here? So, okay, you. Oh, you. So, not C++. Huh? Okay, so even you do not have to implement it. So here's the spaceship. I have a struct called spaceship, and it just contains an int as a member, and let's make this order. Doesn't make much of a difference. And then I have the spaceship operator, and in this case, a defaulted version. I'm just asking the compiler to generate it. And below here, I have a couple of spaceships. I decided I like Enterprise and Amelia and Falcon, but I couldn't decide which one has the bigger value, so it's up to you to decide. In my case, I assigned 2 to both of them. And then I use a static assert to do a comparison. What will be the output of the code on the left? I didn't know a week or 2 ago. That's the reason why the auto probably squeezed in there falsely. And while developing stuff like these, you stumble over a lot of things I at least do not admire. It does not compile, and it does not compile because this is a Clang tool, but by default it uses libstud C++, which ships with GCC. And they seem to have a different implementation. I think, I'm not sure if it is standardized or still to be decided whether you have to include yourself the compare header there. I think what GCC in its implementation does, it does it for you in the background. libc++ and Clang don't do this. You have to be explicit, so I have to switch to libc++ for this example. And then it compiles. And what I'm getting out here, if you start from top to the bottom is, okay, I get my spaceship operator. I can now see by default, in my case, it has a strong ordering, which it returns, which is a new type. You can have strong, weak, and the third one I forgot. Anyone? Partial, yeah, I think it's partial, thank you. And now also the equals operator pops up, which is also defaulted. The compiler generates this for me. And below here in the static assert, I can see what's going on. First, the global operator less than or equal is called with my enterprise object, which calls the spaceship operator and is then compared to 0. So what the spaceship returns, aside from the different types, is either -1 for less than, 0 for equal, or 1 for greater than. And now we have two calls, and that was what surprised me, because I have an invocation for the spaceship operator and another invocation to compare the result of the spaceship with what I liked. Okay, so I was surprised that we are getting two calls there. In all fairness, these are operator calls, they're most likely inline, so I guess the optimizer will get rid of this.
This operator, as you are pointing, is just a comparison with the integers, so that's really fast. You don't care about that.
I am more surprised that we get another function call than that I care. I assume it will be optimized away, especially for this example here. But I was interested in how it was solved. And there's another string to it. In this case, the compiler creates the equals operator for me. But if I say I'm a cool guy and I know what to do, and I have to be short now, so I'm just returning 1. Now I have to return stood strong ordering. Oh my gosh. Now I don't know what to return. Let me try this. Sure if this compiles. Yeah, damn it. It wasn't planned. All right, okay, I failed to make this point. Thing is, as soon as you implement the spaceship operator's contents yourself, the compiler stops providing the equals operator for you. Okay, then you have to implement the equals operator. I'm telling you this because if you start using this feature and, well, most likely you like to squeeze in your own spaceship operator implementation because you have a special type there, then you will lose on the first side the equals operator. And something that worked before can then stop working. But that's the intended behavior at this point. Yes?
And then non-equal, you have to implement it yourself?
Yes, then you have to, the non-equal.
Yeah.
If I go back here.
Is it the full purpose of this that you don't need to implement them and they're implementing for you?
So yeah, I do like to show this. Oh. So this compiles because you can translate here the compiler can translate the equal to the non-equal. That was your point, right? So that's not an issue. The issue is that you're losing in the first place the equals operator, which will result in also losing the not equals. Yes?
When you provide your own spaceship operator, can you default the equals operator?
I think you can. The question is it the right thing to do? Because the question then is, what does default mean? So what is the implementation the compiler provides you with for default? I'm not sure. All the time the compiler bails out to generate something from me by default is for me a sign that I should watch out for some traps and pitfalls. Because otherwise it would do so. But I haven't looked into Spaceship that deep, so I cannot tell you that. There was a talk at Meeting C++ from Jonathan Müller, which was over an hour ago. I think that's a good start to watch. He tells and knows a lot more about Spaceship than I currently do. Yes?
Why is it not comparing the result of Spaceship to 0? Why is it relying on equals operator?
I'm not sure if I understood it correctly.
Why is it not comparing the result of Spaceship operator to 0?
Why is it not comparing the result of the Spaceship operator to 0?
That was changed for performance reasons. We have two vectors. We're comparing less than you have to go one by one through each until you find the first one that doesn't match. But for equality, you can just check for equal size first, and then abort early. And that's why the default does member-wise comparison and not operate the Spaceship equal to 0.
So the answer is it's for vector.
Not only.
Not only, yeah. But it's for performance reason because you can control the performance then better. Other questions? Damn it. All right, then what we have left is you can support a project. You can contribute source code, which is what I like most. You can, if you on the other hand say, well, I write code for my entire day, but I have a lot of money left, donate me something from your money. There's a Patreon project site for C++-insights. And if you say you like something back for your money, you can also buy a t-shirt if you like. Or you can just do something else, whatever you like. I once got the question after I wrote about another feature I released from a person I don't know, but guessing from the title seems to be a little bit knowing at least my last name in German. So the question was, so is it completely Fertig? And the answer is no, I don't think so. Not as long as we are developing new standards, and even with the ones we already have, it's not done yet. But with that, I can tell you, I am Fertig, and that's for real. If you like, I just wrote a new book. It's not completely finished yet, but not everything comes with my name, right? So you can get a discounted version there. And if you like and interested in training, you can also get a little discount here. If you have any questions, I think you can approach me later, but maybe we shut this thing down, or have you still time for questions?
Maybe one or two.
Okay, so if you have 1 or 2 questions left. Thank you. Thank you. So there we have a question.
So easy implementation question. Well, an easy question about your implementation. You just asked for the AST from Clang, and then you asked Clang to convert the AST into readable code, or how do you then make? You did not implement it by yourself, right? Completely.
I asked Clang for the AST, which is basically the same thing as Clang tidy does, if you know that. But transforming it back is putting together a lot of strings. So I can use the rewrite engine of Clang, which Clang Tidy also uses. So I match particular places. I try to match more and more. So currently I can match decals. Most top things are decals. So your function decals, variable decals, and your translation unit basically only contains decals. And in the decals, you have the other stuff. So I match most of the decals. And I can tell Clang to rewrite this declaration section, say a function from line 6 to 10. But what goes in there, I have to make up. So most of the C++ code behind this is std string concatenation. So there is no easy way back. Yes?
I don't think it's just for education. I think it's pretty useful for code reviews as well. I would argue, because then you don't have to write, nah, this doesn't work. You can just show them. And yeah. And do you have any plans that, for example, you showed us the example with the parameter tag that got unpacked. Do you have any plans that for bigger examples, you have something like blank format or something that beautifies the code in the end?
Okay, so the question, I think the end of the question, no, the first important part is you can also use this in code reviews to show people that they are wrong or that you're right, however you like to phrase it. Or yeah, even if you are arguing and nobody knows, you can see probably what's going on there, and this helps. And the other part is, do I have any plans to format the output nicer on the web front end with something like Clang format? And sometimes I think about it, but I have no data how much people use it. Use the online website. You can also install it locally, as I've done, and for your company source code, that's always my advice. And for that, it would be, I think, more possible. Currently, it runs on a more or less low-budget server, so I'm not sure how Clang Tidy fits in there. But when I used it in companies, I often replace it with the normal compiler for short fragments, and then put Clang format after it. So it's a nice suggestion, and I'm looking into it, but I didn't bother formatting it myself, so Clang format would be my choice as well, yeah. Thank you. All right, one final question, if there's one. Nobody wants to be the last.
Can the tool also show some paddings in data structures?
Paddings. I haven't thought about this, and I've never seen it. It most certainly is possible, but then it's a, let's say, custom extension. So I try to, let's say in more than 90% of the cases, I try to only show you what Clang really does. But for some exceptions, I do make things up, like the name of a lambda, things like that. And you're asking about showing padding would be such an extension, but it can be helpful. So I take this as some improvement for the future. Yes, my argument often for using C++ insights is I'm a C++ developer and I can read assembly, but I'm really not good at it. So the session is over. Thank you very much.